Hello, we are Look Left Studio, and for the past 20 weeks, we've been working on building a habit tracking app as our first official project.
We are thrilled to announce that we are in our final phases of beta testing Chronos and will soon be releasing to the App Store and Play Store. We decided to go with the freemium method for Chronos, which means users are able to use Chronos as much as they want and log up to 300 actions until they're prompted to purchase the premium version of the app.
Adding in-app purchases for iOS took more than a couple hours of fiddling and putting our brains together, but we finally got it. There might be a tutorial coming soon on how we got it to work for 4X versions of Godot, since the workflow was slightly different than the documentation.
We went into Chronos with the aim of tackling an achievable project, and we were a little surprised that an app as simple as this required nearly 13,000 lines of code over the course of 20 weeks. But the end is in sight, so we're ready to revamp our main project while in the final stages of testing Chronos.
Look Left Studio was started with the ambition of creating a competitive, multiplayer, roguelike battle royale, and 2 weeks ago, we resumed progress on Rogue Royale. It's a working title for now, and we'll come up with something better once we've made more progress on the game. This project has actually been in development for the past 2 years, with over 30,000 lines of code spread across the authoritative server and the client. We've learned a lot about project management and planning through Chronos, so we're excited to bring more direction towards the development of our main project.
Rogue Royale is going to be a competitive multiplayer top-down roguelike. Think Enter the Gungeon meets Hyper Light Drifter meets Apex Legends with an art style inspired by Hollow Knight. The end goal for the game is to have players spawning in a procedurally generated dungeon, fighting their way against other players and mobs in order to defeat the final boss and be the last team standing.
Instead of building the entire game at once, we decided to break up our development into specific goals that we are calling epics. We're hoping to achieve each epic in about 3 sprints, where each sprint is 2 weeks worth of work. Our first epic is called the Pet Arena. During this epic, we will be building out our simplest characters, the pet characters. One fun mechanic we want is that when a player dies, they become a temporary pet to a teammate until they are revived. That way, you're always engaged and contributing even after you've died.
Our pet characters are going to be very basic characters with a simple melee attack, range attack, a block, and a stun state, so we figured this would be a good place to start development. The end goal of our first epic is to have players spawn into their own spawn rooms, which will be attached to an arena where players will enter and fight it out to be the last one standing.
To get multiple people playing the same game together on different computers, we need some kind of netcode solution to sync players together. We've chosen to go with an authoritative server and client-side predictions through rollback. This implementation draws heavily from GDC talks on Overwatch and Rocket League, so I would highly recommend watching those videos if you're interested.
From what we had worked on before Chronos, we already have a player character in the game with a lot of the basics already hooked up and ready to function with our custom-build netcode solution. It was all done with programmer art, but now we have the first draft of our pet character in the game.
Because we are stepping every single piece of logic by hand in order to precisely roll back and correct for mispredictions, we needed a custom solution driving animations for our player character. If we simply let our animations be driven by idle or physics process, we could have some unexpected jitter caused by rollbacks when we mispredict other players' inputs. Like in this example, these walls don't actually exist on the server, so the local client mispredicts their position when they think they are running into a wall. See how the other client's idle animation is now spazzy? But when we keep track of animation frames and step all the animations by hand during a regular frame and a rollback frame, everything syncs up and we're back to smooth animations. This is accomplished through an animation system. We have our animation tree that we are stepping manually by hand and tracking a history of the active node, blend position, and the animation frame. This way, whenever there's a rollback, we can go back to whatever animation or frame we should be at, step it forward back to the current frame, and not cause any jitter in our animations. One final area we were able to update during this sprint was input prediction and correction. When an action is received from another client, we check this action against our predicted one. Then we look for a mismatch in all the actions. If the only mismatch was where the character's looking, then there's no need to roll back, and we silently correct our future inputs. But if there is another mismatch, such as an attack input we missed, Then we mark this frame for rollback. After that, we update all future actions up to the current frame to match the newly received action. We even have an early out to ensure we don't overwrite an action for a frame we may have already received.
During our next sprint, we hope to add environment assets into the game and refine our character sprites a little more. And that's all we have to share for this past sprint. Thank you for joining us, and we'll see you in about 2 weeks. Bye!